Hey everybody, Brandon with FastDataScience.ai, and this is my Friday face. Yep, what's my Friday face, you ask? Well, apparently, according to my wife, I wear my weekdays on my face. Just like people wear emotions on their sleeves, apparently I wear my weekdays on my face. And so this is my Friday face. I'm happy. It's Friday. It's a good thing I don't do this show on Monday, right? Okay, well, let's go ahead and get started. So this is another episode of This Week in AI. This is the show where I bring you all the latest news headlines in machine learning, data science, and artificial intelligence. All those ones that hit my inbox, I organize them a little bit with a little data science of my own, and then I deliver back to you some of the insight that I gained from reading a few of the more interesting articles for the week. So let's go ahead and get after today. So today is May 13th. 2022. And do you know what that means? Do you know what that means? That means it's Friday the 13th. Yes, it's Friday the 13th. And so today we celebrate wonderful horror movies all over the world, right? Horror movies are great. I love them personally. My family and I really get into cheesy, bad, B-rate film horror, but nevertheless, I thought I'd also share with you in celebration of Friday the 13th and the fact that we're celebrating horror movies, a little bit of crazy, nightmarish clowns that were created by a GAN model. So artificial intelligence is even now starting to give us our own nightmares. That could be a really cool premise for a really scary horror film. Okay, let's go ahead. What do you mean it's been done already? I'd love to see it. Rex in the comments. Okay, let's go ahead and jump into today's show. So today, what did we find sitting in my inbox? We found 130 different articles. 4 topics out of those articles. Topic number one, Apple. Yes, Apple the company. Apple was in the news and there were like 10 different takes on this one story. So yes, I'm going to cover it. Topic number 2, jobs and education. No big surprise there. Topic number 3, everyday machine learning. What are some tools, tips, and tricks? Actually, I'll cover one of those in a second. And then topic number 4 is predictive AI. So there was quite a few articles this week about the use of AI to predict things, or flip that around, trying to predict the future of AI. So they kind of all fell into this predictive AI bucket. I'll actually cover one of those. It's what caught my eye this week. So let's go ahead and get into the first article. And as promised, I am going to talk about the big news happening at Apple this week. What's the big news? Apple loses their director of machine learning over its office return policy. Okay, so let's go ahead and break this article down. Why do I care about this? Look, I know the article isn't about machine learning or artificial intelligence or data science or the cool stuff that's happening in those fields. It's about a person who holds a title that's related to this field. So yeah, sure, this article could be about any high-profile executive deciding to leave their high-profile company because of some return to work policy. But in this case, it just happened to be a director of AI for Apple. And so here are some really cool points from the article that I think personally resonate with me, being a person who works remotely. Number 1, this director and his supporters at Apple, a group of employees there, they argue that commutes are draining on the braining. Yeah, that's right. That sitting in a car, driving to and from work, especially if you're at Apple, you're in Silicon Valley, so you're probably sitting in traffic, that it's draining. That by the time you get to work, it takes time to rev that motor back up, get the coffee juices flowing. And that makes a lot of sense to me. Instead, you can just pop right out of bed, hop downstairs into your office, and get going right away. Number 2, there's some hypocrisy here, Apple. Come on. Like, you really kind of sell products that are geared towards supporting remote workers, but yet you don't support your own workers being remote. I get that one. That's a really good point. And then number 3, they really challenge this idea that Apple says is missing from the at-home workforce, which is this concept of the water cooler conversation, or those spontaneous serendipitous moments that we have where we all of a sudden run into an employee who's getting water at the same time at the same water cooler that we are, and wham, all of a sudden we find ourselves deep in a flow state where we're coming up with new and innovative ideas, and those ideas get translated into the work space and stuff. Whatever the argument is, I kind of get it because certainly sometimes I'm a talker. No question about it. But, you know, I mean, certainly I would find myself, there's only one of me, myself in some of those situations with employees where, you know, I'd run into them or I'd walk over to their desk or something and we'd start talking and we'd come up with ideas. But I would say that was few and far between. And actually, at Apple in particular, these employees argue that the space wasn't really even conducive for that anyways from the get-go. Okay, so whatever it is, this is high-profile stuff. I think it's happening all over, you know, really all over the country and all over the world. Lots of companies are really trying to weigh what a good, healthy kind of work-life balance is, especially coming kind of out of the pandemic, even though we're still kind of in it. I don't know, it's confusing. So really, at the end of the day, what I like about this article is it at least calls out those talking points and provides us with some really good arguments for why remote work is beneficial and maybe even healthy. Okay, so let's go ahead and jump into article number 2. So article number 2, steps to perform when your machine learning models overfit in training. Overfitting is a basic problem which could be mitigated at various stages of a machine learning project. So great article, super practical, super applicable. So I read it and I really like it's comprehensive. It talks about lots of different strategies for dealing with overfitting. But first, let's talk a little bit about like what exactly is overfitting? Okay, so overfitting is a situation where you train a machine learning model on a data set and it doesn't really learn to generalize to other data sets, right? It just learns the very specific nuances of that one data set. And so the model does a really good job in predicting things in that data set. But when you take that same model and you apply it to a new data set, then all of a sudden, of a similar domain, right? Same data's domain, but just sort of new data, right? Hasn't seen it before. All of a sudden, that model stops performing so well because all the nuances that were in that original training set don't actually generalize. The model didn't learn those general patterns in that data set that you would expect a model to learn to be able to apply it to new data that's coming in. So that's overfitting, and this article does a really good job of pointing out that it is a significant problem. I personally have worked at length trying to overcome some of the challenges of overfitting, and it really is caused by 3 essential characteristics. Number 1 is noise in the data. The more noisy your data, that is, the more messy your data, the more likely it is that you're going to build a model that may overfit that data. Small data, right? So small data tend to have less stable variability. So there's also instances or a red flag, if you will, for potentially building in a model that may overfit the data. And then number 2 is complexity, the complexity of your model. So using a super deep neural net with thousands of features that you're feeding to it, you know, on a data set that's, you know, maybe only a few thousand observations, probably going to lead to overfitting. You have a lot of complexity in the model that can learn lots of nuances in that one limited specific data set. All right, so what are the strategies that this article talks about for overcoming overfitting in model training? So here are 9. Like I said, it's comprehensive. It really does a good job of going over how each of these different strategies may help to reduce the impact or the likelihood, I should say, that you're going to build a model that overfits to the training data. So this article talks about dimensionality reduction, which is really just reducing complexity in a model, dealing with outliers, dealing with the noise, in other words, cross-validation, which helps to encourage the model to learn patterns that do generalize across different holdout samples, is what we call them in cross-validation. Early stopping is a technique that we can use where we stop a model from training over multiple epochs at a certain point in its in its gradient descent to ensure that the model is more generalizable, that it doesn't start learning specific nuances of the training set. Network reduction, data augmentation, feature selection. Feature selection is very similar to dimensionality reduction. And then the more common approach lately has been regularization. That is to use penalties on our models for being too complex. So the more complex a model gets, regularization helps to put that in check. And this is particularly valuable in neural nets where we can use things like dropout. And we can essentially delete portions of the neural net in order to encourage the neural net to learn more general patterns rather than very specific patterns related to that training set. Okay, so highly technical, lots of really interesting ideas here for dealing with overfitting. Highly recommend this article. You can find the links in the comments and also at the end on the last slide. I'll hold it up for a second. But really, really super uber practical. Really got a lot out of this and thought it was a great article dealing with overfitting. Okay, if I misquote me on anything, and I'll come for you. Okay, so what caught my, there he is again. What caught my eye this week? Not only did Jason catch my eye this week because it is Friday the 13th, but this article, really fascinating article, predicting others' behavior on the road with artificial intelligence. What? Okay, so this is cool. So this article addresses this fundamental question that like everybody who is not a data scientist has, right? Which is like, why don't we have autonomous cars yet? This is BS, right? You know, Tesla and, you know, all these other companies, these startups, you know, they've been promising that we'll have cars that will drive for us, but we're not there yet, right? And there's a lot of reasons for that, but the biggest reason for that is, well, people. People are really unpredictable sometimes. Not all the time, but, you know, there are minor variations. When you take like 1 million people, say, on a road, there's going to be little, like, you know, brain farts that we have that create noise, right, in all that data and make us unpredictable, right, make us a little bit random. And that's really hard to deal with if you're an autonomous car. You like a system that's a little more closed, that's a little bit more predictable in order to be able to navigate it appropriately. So the fundamental question that people have is, can cars learn to anticipate other people then, right? Can we learn to anticipate what other people are going to do? Which is fundamentally what we do when we drive. We are constantly creating these sort of like, you know, causal physics, right? Where we think, okay, I think this person's going to turn left. I think this pedestrian is going to walk or not, right? And so the question really for data scientists becomes, can models learn to predict behavior? In this particular article, it tackles a research group that is trying to solve this. In the past, what they have found is oftentimes these autonomous systems that leverage artificial intelligence treat pedestrians in particular, so these are humans walking around the environment that don't have a car, or bike riders, for example, but it treats those actors in that field, or those agents, as either too simplistic, okay, I'm going to assume that that person will go in a straight line, for example, too conservative, let's just assume that there's no people, that there's no people in the environment, or if there are people, that the car just stops, right? We just don't move it. All right, let's wait until the people leave. Okay, then we can go. Or it's too focused, right? It's too focused on one individual rather than appreciating the fact that it's a dynamic system, and often cases you have multiple interacting individuals and their interactions affect their own behavior trajectories, right? So in this particular article, they talk about building these people prediction models or behavioral prediction models. And actually, they take kind of a simple approach rather than a highly sophisticated, like, integrative approach. And what they do is they build models that stack on each other. So you have models that can do things like this. One model might predict whether or not a person is a pedestrian. Another model might support that by predicting whether or not that person is likely to move. And then a third model might predict which way is the most likely direction that person is going to move. And so you stack these smaller models on top of each other. You improve the interpretability of the machine learning that's affecting the decisions that car is making. And that also becomes some information for the individual who's sitting in that autonomous car. It makes it more explainable. You can see why the car is making certain decisions at different times. And so here are just a few examples of some of the different stacked models that this team has built to try and help cars determine what pedestrians and other actors in their environment are likely to do. In other words, predicting their behaviors. Now, how we deal with some of those spontaneous brain farts that I talked about, it's a technical term, by the way. How do we deal with some of those spontaneous brain farts that people sort of experience whenever we're just out and about being human, because we're not closed systems, we're open systems, so we have all kinds of things happening to us, streams of consciousness, too much coffee, not enough coffee, whatever it is, right? How do we deal with that? We don't know yet. But ultimately, this is a very interesting approach to a very challenging problem, and one that I think is really cool. And a lot of us who are data scientists at many levels can kind of understand what's going on here. It kind of starts to make sense. Now, these models are scoring with streams of data constantly, so the systems that support that scoring capability are pretty sophisticated, but the way in which these models are stacked, I think, makes a lot of intuitive sense. And from an explainable AI perspective, I think there's a lot to be said here for user experience as well, and really creating a good user experience for understanding the decisions that car makes. Okay, so with that, I appreciate your time, your energy, your attention. It is Friday, and it is Friday the 13th, so go watch a horror movie tonight with your loved ones and hold their hands tight. Enjoy your Friday, enjoy your weekend. Here are the links to the articles that I talked about today. I will also include these in the comments below. Please share, subscribe, do all the things in the social world that you should do. And there's my buzzer. I am done for the day. So have a wonderful weekend, everybody. Bye.